Okay, welcome everybody. Today is Thursday, June 14th, 2018. You are in the Kubernetes SIG Architecture Community Meeting. I am your co-host, Jay Singer-Dumars, and we're going to go through the agenda, which is available after the fact at bit.ly/sig-architecture, and that's where you can pull up the agenda now. We have the first item on the agenda is the further continuance of the conversation around volume snapshots. So I'm going to go ahead and turn that over to who? I'm not sure who's representing that. Oh, you'll be? Okay, great. All right.
So if I could give a little bit of context, 2 weeks ago, we started talking about volume snapshots at SIG Architecture. The purpose of this was mostly to get approval to pull the snapshots design, which is currently an external controller with CRDs, into the core of Kubernetes. As a reminder, the purpose of this is not to do a deep dive API review. That can be done offline. The purpose of this is just to get a thumbs up from the stakeholders on whether we're okay moving forward, pulling this in tree, basically. And so with that, I'll hand it off to Jane.
Okay, sure, thank you. So the main goal for this project is to provide a standardized snapshot API for the basic function, including creating, listing, deleting, and also more importantly, like restoring snapshot to volume operations. And on top of that, we can build up more like top-level functionalities using snapshot. And so just give like a quick refresh of what we talked about before is volume snapshot and the volume has very close like relationship. From the figure you can see on the right side, you have volume. In Kubernetes, we represent with PVC, persistent volume claim, and PV, persistent volume, two API objects. And for snapshots, you can create snapshot from a volume, and then you can restore the snapshot to a volume. And so what we propose is using two API objects. One is called volume snapshot, the other is called volume snapshot data, to represent the volume snapshot. So you can see it's very similar to the PVC.
Sorry, you're presenting by Hangouts, not by Zoom.
I'm going to share it.
Don't worry,
We're fixing things.
Okay. 1 second.
You could just join the Zoom.
Yeah, you're not actually presenting to the people in the meeting.
She is now.
Oh, so
no.
You can
No.
join
No.
Zoom
Join
first
the-
and then share.
Yeah, you have to share through Zoom.
okay.
It's visible now.
Oh,
You can see it? Okay.
Yeah,
Now,
we
okay.
do it. She'll drive.
Okay.
Yeah,
Just ask for Slack.
Yeah.
Okay. So right now it's okay?
Yep.
Good.
Okay. So yeah, let me know if you have problem. And so for snapshots, there are a variety of use cases, except the traditional like data protection, you can use as a backup and recover data. And it's often used for like replicate data, distribute data migration. And also very often we see people need to change their volume and for different reasons, so they can just take a snapshot and recover the data from the snapshot. So that's why now SIG storage pushing this feature very hard, and is one of the top on our list. And for out of tree, we have a variety of issues, problems. So for example, if we put the snapshot API out of tray and the PVC in tray to represent volume, right? And the user will get some like confusion and how to use them together. And also it will definitely generate some fragmentation and has portability issues. So it's hard to provide out of tray and the in tray API altogether. And so also more importantly, for some fundamental functions we want to provide, including in-place restore we talked about last time. Although the API itself has not finalized yet, but the workflow is basically provide this in-place restore. Cannot build without in-tray API, snapshot API. and some like pre-post preparation before taking snapshots. In order to keep data consistency, you have to prepare your file system, like freeze file system or even unmount. And those kind of functions has to be handled in Kubernetes. And so out of tray API won't be able to solve this, provide you this automated functions for preparing application file system before taking snapshots. So that's all the major problems we have auto tray, and so that's why we want to see a SIG architecture. Like any concerns if we want to put it in tray, and we already have a community design proposal, and also we have API, actually APR for the API, in-tray API, so people can start review it. Any other questions?
Yeah, I had one. Sorry, was somebody else have one as well?
Oh, yeah, I was just going to ask if SIG has reviewed the proposal.
The initial proposal we did review, and Jean went to, I think you went to the signal preset. So we did the initial proposal, but we didn't really follow up.
Yeah, the new one. So it doesn't change much. It's done some maybe details. So I can put the node team member into the reviewers again. Yeah.
I'd like to. The first three items seem to me like things that many types of out-of-tree extensions have. So I think that's not what I want to focus on today. The last one seems unique, but I didn't understand the last one. Can you talk a little bit more about the last bullet and what is hard to do? Let me go down all those detailed items on the last bullet.
Right. So the slides I have for in-place restore for pre-post. So here it just last time I presented this basically as a simple snapshots example workflow. So right now manually people need to do is first, for example, you have database application, you have to run some, let's say, lock your database, flush your data, freeze your file system, and then you can use some command to create snapshot. And after that, you need to unlock the database and freeze file system. And so this is the manual way if you do taking snapshot.
Right. So step 3, we would like to have a portable solution.
Right.
Which you're offering.
Right. The API.
And so 1, 2, 4, and 5 might be orchestrated by like an operator, and then that would call 3.
Well, 1 and 2 would be extra steps that the user would define as commands that must be executed before and after a snapshot in the pod. So if you show that proposal,
the user does have privilege to do 1 because like they're operating the database.
Right.
They not have privilege to do
the second
to do
or
2
or the unmount. Yeah.
Why aren't those containerized operations?
They would be. So if you look at they could be. So if you look at the proposal, can you go to your pod proposal where you have the pre-post hooks? So it could be a set of commands that get passed, or it could be a container that gets executed.
Yeah.
We haven't decided on what the details are, but the important point is that in order to enable this, we kind of need kubelet to be aware that there is going to be a special step before a snapshot is taken and a special step after a snapshot is taken. We need to hook into that life cycle.
I don't understand why that.
Wait, can I add my hand up? Yeah. Sorry, I know there's like when they're getting like 8 or 9 people in a room, it's really difficult for remote folks to get a.
Quinn had a question also. Right now, we don't have the view of the gallery view anymore on the screen. Is there a way to get that back on the screen so we can see? No.
I don't know how that.
I think I don't.
Can you kill this?
Yeah. Okay.
If you have 2 screens with Zoom, you can do it. So my comment here is that like if you go back to that slide where you had those 5 steps, I think one of the things that we've done a lot with Kubernetes is that we've broken things down into granular features, and then we found that those features can be used in other ways, right? So in my mind, like, and I think about there are going to be situations where people are going to have different strategies for doing snapshots. The idea of being able to freeze a file system is a separable feature from actually driving a snapshot. And a snapshot ends up being a workflow on top of that. So have you considered exposing more granular sets of features, like maybe a volume freeze feature on the pod or on the volume? I'm not sure exactly where that would sit. And then that actually lets us have that idea of like driving the snapshot workflow as being something that's separable. And we may find that the volume freeze feature ends up being useful in other contexts.
Yeah, that's an interesting idea. It's like another volume operation. Right now, we are also trying to propose some general API called volume operation to do many different types of volume operation. But one thing I'm a little concerned is to prepare application and taking snapshots is very time sensitive. So we don't want to like have extra delay. So because you are going to pause the application. And
well, I mean, we're going to go through an external cloud provider to actually make the snapshot anyway. So we already have a workflow that's going to involve, bunches of components. Doing a snapshot, depending on the cloud and actually verifying that, is going to take a bunch of time. And as we look past the big three clouds, there's going to be a whole host of ways that you're going to want to capture data within the volume that are going to, have different amounts of coordination. So this is not sort of a local type of thing already. It's already exposed.
That makes sense. But I think from just user point of view, maybe to minimize the delay would be like better if possible. Yeah, but definitely I think it's interesting idea to provide a separate volume operation to freeze file system, so other use cases can use these operations except snapshot. So that's a possibility, I think. But some user might also need to unmount file system to have the absolute data consistency. And for unmount, right now we handle through Kubernetes Volume Manager. And so user cannot just directly unmount their file system.
Are there any examples of actual applications that require unmounting?
So it's recommended by the best practice in, let's say, some GCE PD documentation.
I've seen it for Amazon as well, but I would hesitate to add functionality like that if there's no actual need.
Yeah, so since we can contact the PD team again to see whether they have some comments about that. But right now it's the best practice in their document. Yeah.
Yeah, because you'd have to, if you have any open files on those volumes, they've got to get closed before you can unmount. So that's even worse in terms of shutting down an app and having an outage. That's a full outage because those files have to be closed.
Yeah, I mean, ultimately, I think with the pre and post hooks, what we're looking for is some way to be able to signal to the application that's running that, hey, we're about to take a snapshot. Please prepare for that. Do whatever you need to do in order to make that happen. If you're a database, that could mean doing all the flushing that you need to do. And if we don't have a hook to do that, we could go ahead and take the snapshot without that happening, but we could take an inconsistent snapshot. So ideally, we want some way to be able to signal that a snapshot's about to happen. And then after the snapshot's taken, signal, hey, we're done, go ahead and resume.
Right. So we have been able to do everything except for unmounting using an external set of tools. So yes, there may be a slight more bit of a delay there, but in terms of being able to run pre and post hooks to freeze and unfreeze and then take a snapshot, it's certainly possible out of tree.
Yeah, I think it's possible. I think Jing took a look at that approach, and it looked like you guys were doing kubectl exec into the container to signal that a snapshot is going to happen. Is that correct?
Yeah, using Speedy for it, but so not shelling out, but same protocol.
Right. So I think the problem with that approach, as we saw it was not necessarily applicable in all cases. You kind of have to be aware of what the application is that you're execing into and what the capabilities are. if we could make this a first-class field within the Kubernetes API, then the applications can essentially write their own receiver for it and say, okay, when this happens, I will handle it in this way.
But that still needs some kind of handshake with the application
Yes.
to do that. So the image has to have that command and the...
Yeah, I don't see that as any different. I mean, we have to have a command to run fs freeze, or if you put it in.
I mean, I think the difference is that it would be an established contract between Kubernetes and the application versus something that the application has to be aware.
But we have all sorts of contracts in Kubernetes right now that don't involve extending our core API objects. I mean, yeah, and again, especially for something that's still very early like this, where where it's still being developed, I think codifying that into something that we're going to live with forever. It seems early.
And I mean, we wouldn't go GA with this immediately. Obviously, it would go in as alpha. We'd see if it was viable, and if we decided that it wasn't viable for whatever reason, we had the option to change it or pull it.
Yeah, I mean, again, trying to think of more generic features that we can extract out of this. We already have this idea with probes for readiness and liveness probes as a domain-specific way of how do you communicate something to the application. Mm-hmm. Do we want to actually have a generic set of here are different types of hooks, and we actually end up looking at this as generic lifecycle hooks with an extensible namespace for naming those hooks, and then a way to trigger those, right? So, because I think we've seen this pattern where we're going to see an explosion of new ways that things outside of the workload want to start interacting with and hook into the workload, and it's not going to end with just the volume management stuff. So I think like maybe taking a step back and saying, okay, can we do volume snapshotting by breaking this down into a bunch of different features that have wider applicability?
So speaking of the lifecycle hooks, do we have any data on usage of post-start and pre-stop hooks?
We don't have.
Because my impression is that those aren't nearly as widely used as init containers and just receiving SIG term, for example. They have a bunch of quirks and kind of problems. Like you have to actually put extra stuff in your image, generally, for example, for those to be useful. So I don't think those have worked out super well, but if we had quantitative...
So I know pre-stop is used extensively in production environments. Like I don't actually know of, like all of the serious production deployment applications I've seen for like big, stateful JE apps, every single one of them has a pre-stop hook after the first time it breaks.
So
okay, cool.
And also a lot of like try to provide the different type of the pre-start hook. We have a lot of those requests, but none of those it is solve all the problems. So basically, we don't understand how the user really using that pattern. We may understand one use cases or two use cases. Every time we look into and there's the underneath of the new use cases coming to us. So that's what basically we are doing to really propose new way to achieve this one. Actually, I agree of the Joe's point, because we don't have, we need more use pattern to provide a generic solution on those kind of things. Those hooks came to the signal almost every month. They have the new hook and they want to do that. Like for example, most recent, there's the NVIDIA came up with the new hook for their GPU support. But the problem is that hook is specific for the GPU attachment. So it's not generic enough. So that's why we try to collect all those kind of information.
Yeah, and there's also been a proposal for defer containers for a while. There's the effort on trying to get debug containers working. So it's not clear to me that having in-image code to invoke with the hooks is better than having a separate image that contains.
Yeah, we'd be open to looking at a generic solution for some sort of way to signal into a container. Yeah. We're not completely tied to this approach. And I also don't want to rat hole on just this as the primary issue. If we take a step back, I think a couple of other issues are the fact that if these API objects live out of tree and you have an external controller doing operations like an in-place restore, where you have we're basically swapping out PV from underneath the PVC. It requires coordination with the in-tree PV/PVC controller. The in-tree PV/PVC controller doesn't know that there is an external controller that is trying to operate on these objects. We need to have some sort of coordination between the two, and we'd essentially have to recreate the logic of the PV/PVC controller in this external controller, have coordination between them, and it gets super cumbersome.
I'm not presenting.
I had a question a while ago. Can I ask it now?
Yeah.
I wanted to just understand what the thinking is around conformance. So if we put this in tree and we say these are the standard ways that you make snapshots and restore snapshots and etc., is the expectation that every volume provider has to provide all of these functions in a consistent way, or are there different levels of conformance? Could I build a volume controller which, for example, doesn't support snapshots?
Just like any other volume plugin, you can define what the set of capabilities are for your volume plugin. At a very minimum, we require mount. Beyond that, you could do provisioning, and snapshot would just be another optional feature. We already do resizing, for example, and that's in tree. So this would just be another optional capability that a volume plugin could add on.
So do we have any set of tests? So then for the node, we have the node conformance tests, and we're actually looking to figure out how we can take those tests and make them useful as cluster level conformance tests to test that surface area. Are there tests to determine whether the CSI plugin is implemented correctly or that a volume works correctly? Because right now we have almost no coverage, as far as I know, of PVs or PVCs in conformance tests.
Two different types
because
of
none of the
conformance.
volume sources are portable.
Yeah. The CSI volume conformance is going to happen before 1.0. Right now, we just cut 0.3, so it's on the to-do list. For Kubernetes conformance for volume tests, we have a task this quarter to go and spec that out.
Okay. Yeah, because one thing I had suggested in some issue somewhere is that we genericize it a little bit some way and say you must have a storage class that has these properties, and then we can test that independent of what the actual source is for a particular provider. And if they set up the default storage class for that provider, then that can be kind of a generic portable set of tests. And we need to figure out whether it belongs in a special profile or not in conformance. Like, I think we're going to need some kind of cloud provider profile or some common sort of profile that's not 100% required for everybody, but people who implement that additional functionality, at least we have consistent behavior.
Yeah. I mean, go ahead.
Well, from a higher level, I just want to say from an apps perspective, policy-based data integrity orchestration is something that's desirable in general, right? So people want to be able to say, use a cron job or use some automated orchestration in order to periodically snapshot their data. And some people are even advanced to the degree that they want to be able to turn those snapshots up and verify that the snapshots actually exist. If we do this in tree, we provide a primitive that allows for policy-based, portable, policy-based orchestration across clouds. Moreover, from SIG storage, I think pretty much all of the members of SIG storage are in general supportive of implementing this feature, because the majority, aside from the big 3 clouds and the other 2 clouds, which also implement snapshots, the on-prem storage providers all implement this feature to some degree or another in a way that can, well, the ones that participate in SIG storage, Joe.
Yeah, but what I'm saying is that there's a ton of people that are running on-prem that don't have some sort of, Hitachi network SAN or anything like that, right? So, and those people aren't going to show up in SIG storage, but I think you're really, there's a sampling bias with respect to, the people who show up are the ones that care. Of course they can.
We do have a bunch of folks, Gluster and Ceph and a bunch of on-prem storage deployments.
What I'm saying is that there's a lot of folks that run without any of that stuff also.
But
even if you're using LVM, there's the big question. This is what Justin's bringing up, of what do you do, after that? So and Gluster and Ceph are both Red Hat also, just in terms of the vendors that are showing up here. So
we have, folks like Portworx. There are other storage.
No, I'm not saying that there aren't on-prem vendors that actually work here on this stuff. What I'm saying is that there's a lot of folks that are running without
but there are folks that are running without dynamic provisioning, right? Dynamic provisioning makes using storage so much easier. But there are lots of, especially on-prem storage systems that don't support it.
Well, yeah,
think
so
my-
that will have to
Eric's
figure out
got his hand up
conformance
too.
as well.
I think actually, I think my general point was just that even for those people who don't have the capability, because we're not saying that it's required for every cluster to implement it in all cases, for those people who do have the capability and have the capability in multiple environments, I mean, they feel like it's valuable and they feel like they want to be able to build this policy-based orchestration across their clouds and their on-prem environments and just have it work. And to be very confident, because it's a core feature, that it works in a portable and consistent way.
Right.
And I think that's kind of important.
Eric?
I would just like, I think Joe made a good point that not everyone's represented here, but I couldn't quite tell what the next deductive leap he was making. Could you specifically state what conclusion you draw, Joe?
Well, I think what we're going to see is that there's going to be, there's going to be a large amount of variability here. I think that there's something instructive in terms of the stuff that we did early on with ingress. Ingress is not universally supported. There's a lot of variability there. The goal out of ingress was to have something where, there was something that people could, assume is there and that they can actually depend upon. I'm not convinced that we're going to see the level of predictability and uniformity that that y'all are talking about here.
So what conclusion do you draw then based on the fact that it would not be uniform?
I think that like trying to overgeneralize this, I think will probably lead us in the wrong direction. So I think that it's like we should aim to find as much commonality as possible here. I think all this stuff can be done out of tree. I think just that if somebody wants to have these life cycles, we can all those patterns can be done using our extensibility mechanisms. I don't think that we necessarily need this stuff to be in tree to be able to get there. And then adding on top of that, as we expand the idea of conformance, I could see at some point we have a conformance profile that involves dynamic volume provision, that involves, snapshots. That's a separable issue in terms of predictability from what's in tree and what's not in tree.
Okay,
So snapshot is a basic storage functionality. Every storage supports that. So
my Raspberry Pi doesn't. I mean, like unless you do right?
So I'm from OpenStack Cinder, right? Cinder has like over 100 backends at one point. That's a required functionality. That's so when you're saying that it's
but like Cinder is part of the OpenStack world. Where,
yeah. I'm just saying I'm just talking about storage. You're talking about what storage supports snapshot. This is like a basic functionality. It's required.
Excuse me, who is speaking?
This is Xin. I work with Jing.
Can you please turn on your video if you would like to speak?
Okay.
We have people raise their hand if they want to turn to speak.
Okay, sorry. Okay.
Thank you. Matt has had his hand up for a while. Matt?
Yeah, so, there's kind of the practical thing here, right? If we're going to support this out of tree, then this means that the tools that have to support it now have to go around and support. You got to build external tools to deal with like app operation that deal with all of this and know how to talk to all the varying cloud providers, right? It pushes some of the work kind of into that app automation tool. At the same time, a whole lot of storage vendors do support it. So would it be practical to say, you know what, this goes in as an alpha feature, knowing that it's probably not completely right, but by doing it in alpha, we can learn a lot. We can iterate on it, and that will push more people to come raise their voices, because some alpha features never go in, some never go anywhere, but it's an opportunity to really get the ball rolling because we have momentum.
Yes.
Okay, so Joe's got his hand up, and then Brian.
So I agree with you. Build it, test it out, get feedback, iterate on it. All that stuff can be done out of tree, right? We're trying so hard across the architecture to limit the number of features that we build in, to build extensibility points that are widely usable. Like I would totally be supportive of generic hooks. I'd be supportive of let's find ways to freeze file systems, right?
No, I understand that. Sorry, I just have a question before you respond.
Sure.
Which is, what do you mean by out of tree versus in tree? Do you mean Kubernetes master by in tree?
By out of tree, I mean external CRD versus internal API.
Okay, so I disagree with that distinction. We are moving towards CRDs even for like all new things. Yes. And unless it's required for performance reasons to be built in, we are going to be using CRDs. So do you specifically mean code in Kubernetes? Is that what you want by in tree?
Ideally, I want both an internal controller and internal API. But
what do you mean by internal?
by controller that is built and shipped with the Kubernetes binaries, instead of a controller that is an add-on as an external
controller
binary.
manager is not going to be. Sorry.
So, for example, the PV-PVC controller or the attach-detach controller today are
in controller manager.
Are part of controller manager.
Okay,
Ideally,
so you don't actually mean in tree. You mean in controller manager
Correct.
in the Kubernetes release.
Yes.
Okay. So it could be in a different repo, for example.
Sure. Yeah, that's fine.
Okay.
Yeah, but why does it have to be shipped as part of Kubernetes? I mean, we don't
because
ship
we've actually done an external prototype, and the challenge is getting folks to install that external controller. It just doesn't work. Like,
well, then they must not care about it then.
So we have
Okay, so Matt,
I'll shut up.
Matt Freena, then Daniel, then Eric.
Matt left Eric.
Yes.
Yeah, I do think, if the whole reason of putting it in tree is to make it accessible, we're probably running into a problem because we're telling a lot of people to do a lot of stuff in ways that needs to be otherwise installed as part of your setup time. And so, if we're saying for this in order to get people to do it, that then makes the argument for all of these other things like the application controller and all these other things that we're working on, right? That they all need to be in tree so that way it's exposed to people. If we're going to tell some people to be out of tree or out of the core and it needs to be installed, we probably need to figure out what's the line for this is in versus this is something that needs to be discovered. And if one or two people have the problem of it needing to be discovered, then we need to make it easier for everybody, right?
Can I respond to that?
Yeah.
So I think the challenge is if this was a completely isolated feature, we would have no issue having it out of tree. The problem is that the entire volume subsystem is already part of the core Kubernetes API. Those controllers are shipped with Kubernetes. This is the one piece that is not. So it becomes really challenging to integrate it all together when part of it is in tree and part of it is not.
And I think that speaks to the user experience and to consistency. If part of a feature is in tree and part of it is out, then that is difficult for people to navigate and understand. Let's say, what storage is in here? Why do I need to go elsewhere for just a piece of it, right? That makes it, that's that cognitive figuring stuff out thing. It's not like finding storage versus not. And so I can understand that.
Okay, Daniel?
Okay, so there's sort of two questions here with in versus out. One is where do you put the API group? One is where do you put the controller code? The API, literally the only reason for adding this to the built-in API, nobody here has mentioned yet, which is the built-in API is in a particular group version. You want this to also be in that same group version because it's a coherent feature together.
Yes.
You cannot have part of an API group version in a CRD and part of it as a built-in resource because things are distributed by group version. So that is the only reason from an API perspective to co-locate.
Well, that CRD doesn't implement API versioning yet.
It will be soon.
It will be soon. Okay.
All arguments of the sort like CRD doesn't do X yet are yet.
Right. And so sorry, just to clarify, which group version is that?
So the group that we want to be part of is storage.kdas.io.
And what's in that group now? Just storage class?
We have storage class, volume, attachments, and a couple other things that I slipped in my mind.
Okay.
Yeah. So
I'll go look at that.
So the second question is about the controller and how do you add a feature without breaking the world. You can fork the controller, turn off the default one, and have people run your external controller. I don't see a problem with that, other than some cloud environments may make it difficult.
Do we have a generic way of turning off controllers?
Yes, but it requires passing a flag to controller manager.
We could make that decision if we're going to pull the
volume
controller out.
When you get like buy-in and everybody's happy with it, then you just you have a fork. So you just
yeah. The other thing I was going to suggest is just move all that code out of Kubernetes master. So you could, to make it easier to do these kinds of extensions and flaggate them or whatever.
Yeah.
Definitely the highest touch part of this are the pod changes, and those we need to be very, very careful about. For the other things, if we can find a way to say, so in the scheduler context, for example, we don't have folks from scheduler here today, but they're looking at turning the scheduler code into a framework so people can build their own schedulers. And then what you would do is you'd either turn off the default scheduler, or we have a general pattern that I have an issue open to actually make it a more concrete, similar pattern, but of specifying the controller that you actually want to take over a particular resource, right? So for a scheduler, you can specify the scheduler name. For deployments, we have a hack for using your own rollout controller. We also ingress, it's an annotation. We've talked about doing this for HPA and other controllers, right? So then you don't even have to explicitly fully turn off the built-in controller. You just say, look, I want this other controller to handle this resource and train the built-in one to ignore all things that are labeled that way.
Yeah, for example, with like a locking mechanism on the things in the controller.
Effectively, that's what it is. It's like a sharding mechanism.
The last thing I wanted to say is I agree with Joe that if you want to change the default behavior that kubelet enforces on a pod, then adding lifecycle hooks or some other maybe not that exact mechanism, but adding some extension point in the existing type. I would rather go that route than add a special thing just for.
Yeah, that's fair. I think the biggest argument that we have left is just consistency of the API. Having snapshots separate and having, for example, the PVC object being able to say, I want to create a new PVC object from this snapshot, and then having that as a CRD and not being able to do that.
And again, just to be clear, like you could go the other direction and move everything that
Sure.
exists there into.
Eric is up next.
So I would just say that we've been working on Cloud Controller Manager. I believe that there was, I don't know if there's still, but there was some cloud-specific code in PV Controller. Now might be a good time to just kind of revisit that. And
Yeah,
you can solve two birds with one stone.
Yeah, we have plans to do that.
Because the choices are, you're saying it has to be built in, but as people have pointed out.
But to be clear, what we're asking for in is just the control logic, not the implementation of the volume plugins. That would be external with CSI. So the what we want in tree is going to be just the common controller logic that implements the lifecycle. When it decides to do the actual snapshot, the logic to do that for any given storage system would be completely external because of CSI.
So my only thing was, well, basically I was going to say pretty much what Daniel said, that for API consistency, it doesn't make sense to put it in another place. But the point that you could move the whole thing over, whether that's realistic or not, yes, you could in theory do that. From a higher level, though, it feels like there's a missing part of the storage object model with respect to snapshot, because while it's not a thing everywhere, for most of our users, it is a thing. It is part of the CSI. And it is something that people are trying to use now and want to use now. And we don't have an API object that represents them and allows them to interact with it in a reasonable way. The interaction between persistent volume claims, and snapshot is so tightly coupled that I can't imagine having this object live outside of the same group. And what I can't wrap my head around how I would use that with stateful set. I can't wrap my head around how I would use that with deployment. It just doesn't make sense to me. And that's what I work on and spend a lot of time thinking about. So I don't know what that would do for our average users.
Joe, you were next in line.
Yeah, I mean, just wanting to have this stuff line up in the same API group seems like a silly reason to move this stuff in tree. I mean, we have places all over the place where we have something in one API group managing and orchestrating objects in another API group, right? You look at, replica set versus pod is a great example there. So I think, if we, there's other places where we have these connections all over the time. So I'm not sure, that carries any water with me. I think some of the question again is does snapshot belong to, does it need to be a core feature for it to work? I think we can get a long way, and we have existent proofs both in the prototypes that SIG storage folks have done, but also in work that's been done outside in other projects. In terms of actually, like, if we can add these features, the fact that you're having a hard time getting people to install and test this stuff and move it forward, maybe to me that sends a signal that maybe this shouldn't be part of the core, right? I mean, like, if the only reason we want to move into core is because that's the only way we can get people to actually notice our feature, maybe the feature is not that useful, or at least not that widely. Maybe the gestalt hasn't moved to the point where everybody realizes they need it yet. That seems to be the wrong way to do it. If we get to the point where we say, like, every single time people install Kubernetes, they have to install this other thing, maybe we should move it inside of the core. That is an argument that carries more weight with me, right? I think we look at DNS, right? DNS started as this add-on, and now we've gotten to the point where it's like, it's really kind of necessary. It's really part of Kubernetes, even though it's not officially part of Kubernetes. If this snapshot service got to that point, then I think we'd be having a very, very different discussion here.
I think that this is one of those things that people don't know they need it until they need it.
Yeah.
And then they're like, where is it?
Yeah, I mean, so I'm just responding to Clayton in here. I think that backups as a concept and driving backups is something that people are going to need. But volume snapshots are one way to do backups.
They are.
Right?
But
Go ahead. Sorry.
I would like to point out, I would like people to wonder, who are wondering if this is useful, to go and look at how, like, the backup instructions for popular workloads that are being run on Kubernetes right now, including stateful workloads. And look what people are doing on the largest public clouds and what they're doing on-prem in order to back these things up. Now, I don't agree with this particular model. Like, this is not how I would back up my databases in production, but this is how users are doing it. These instructions come with the application. And on IaaS and cloud providers, they are using volume snapshots, and AWS, GCP, Azure backup instructions include snapshots as a primitive to use for popular workloads. So the fact that we don't support that in Kubernetes, to me, is a gap. It's not.
But there's ways to support it without actually building it in, right? I think, like, we got to move to that world where we support things without actually baking it in at a core level. I'm sorry, Eric, you were next.
I totally agree with you on that point, though, but not this thing.
I think I just understood what Ken was saying, and tell me if I got this right. You're saying you would like, if this were in core, or this were shipped in Kubernetes, you would have stateful set be snapshot aware and have like a snapshotting feature in the in-core API. So, well, let's say that if your answer is maybe, then say yes for hypothetical purposes.
Sure.
So then the question would be, would we allow a dependency from a core controller out to an optional thing? And so, I mean, maybe, I don't know. Do we have any precedent for that?
We do. There's controllers that detect whether things are installed based on whether the API group is available.
Yeah.
Like?
There's several things. I have to go dig them up.
Okay.
HPA, I think, is one of them.
That depends on dynamic provisioning, doesn't it? Because it spawns PVCs and expects them to be provisioned.
Dynamic provisioning is in tree, though.
The controllers aren't.
But let's take that example. If you want to back up a stateful set, would we build that in the stateful set and add more features into that sort of thing that's already, pretty chunky? Or instead, would we build another controller that actually pairs with the backup system, reads the state out of stateful set, and coordinates it that way?
So that, to me, that is a difference between the types being in tree and the controllers being out of tree, or both the types and the controllers being in tree. And so, like, for dynamic provisioning, the types are in tree, storage class is in tree, and then external controllers can act on those things in provision.
Ingress and network policy are other examples of in tree.
Yeah.
I feel like there's not much objection to this big type being in tree. I'm sorry.
So I think Clayton
yeah.
I was going to say, I think Joe raises the really good point of even though I personally fall in, the reason I asked the percentage is because I think in the long run, snapshots are probably, we could spend a lot of time debating if there's a better abstraction in place. I respond to Joe's concern that we rush an API design that we will live with forever, and having things in the same storage group in the same API group is not enough reason to do this in and of itself. There is nothing that necessarily prevents us from going a snapshot in an alpha state in an API group and then moving it into an API group once there's enough consensus. I think this is the challenge of, this is the third or fourth thing where we have run up against, we want to make a change that makes users' lives better. Every choice we make has a lot more impact than it did early in the project. And so it feels like the right thing to do is err on the side of being a little bit less perfect about the ideal design in favor of all of the things Joe's bringing up, because we have to make these choices and these trade-offs at some point. If we can't make it now, we're not going to make it the next time. We just keep kicking it down the road.
I would totally love to see, let's break this down in more granular features that are targeted at the things that you just cannot do outside of having stuff in tree. Things like file system freezing, dynamic mount, unmount, a generic hooking mechanism for describing and injecting hooks. That all seems like things that this stuff would take advantage of, but and they could be useful in a whole bunch of other different ways. So like with the hooking, you could actually say, hey, application, do your generic domain specific, backup, and then store it into this volume that I dynamically mounted in so that I can then go ahead and squirrel that away, right? So that's a different way of doing backing up that reuses a bunch of the primitives that we've been talking about here.
Eric?
I'm not excited about a Kubernetes where the user thinks on a regular basis about hooks. It seems not declarative, and it seems to not work well with the direction we're going declarative. So the hooks, to me, if we do that, it needs to be more like an infrastructure plugin than an API. That's all.
There are going to be things that are snaps that are point in time. Send this signal. Pre-stop, post-start. The snapshots are temporal. I mean, we're going to have things that are point in time things that don't map cleanly into the declarative mode. I mean, we don't say, I wish that there would be a snapshot of this thing, right? Like, that's just not the way it works.
We should take pains to hide those.
I agree with you on this. I think the operation itself is imperative. It's not declarative. This is also making me a little bit concerned about why we just the reason we want to into the same API group, and because it is pollute our kind our approach on the API, the Kubernetes API. But another thing it is, I think, I understand that we do have the problem, Kubernetes overall have the problem, feature discovery, best practice to the different type of the enterprise user or all those things. We need to solve. Snapshot, actually the feature show us this kind of problem, and we need to solve this one. Actually, even like how to spin up the cluster. And I keep getting that email. Even now, we start up cluster API work. Still, people ask me, what it is the way to speed up the Kubernetes cluster, even on GCE? No, people don't know because it's difficult to find. So to feature, and even there's a feature, there's so many solutions. And what it is the best practice for a set of the end-to-end solution, that it is hard. So I still think about it's a good idea to start from out of the tree, provide a solution. Then SIG storage own that one. So you could have your own SIG storage best practice and for all those environment. And then that it is the way we can start from. And if we think about this is the best practice, and in the future we think about this is Kubernetes, how handle storage for the different workload, especially for the stateful workload, then we could come back and talk about this is entry or not entry. So that's kind of the best way to.
I think to a certain extent we've done that, and we're getting to a point where we feel like the viability of this feature requires it to be entry. If that's not what the group feels, I think we'll try to keep pushing on the external. But
so let me ask Daniel. I just want to respond to the what is the group boundary, API group version boundary, and this is either me telling you all how it works or you all telling me how we need to change it. But sort of the decision that API Machinery has come to in the last couple of releases is that the group boundary is resources for which it doesn't make sense to turn some of them off and have some of them on. So if there is a possibility that you can have one resource on and one resource off and that would break the cluster, then or if that's a desired behavior, then they really ought to go into different groups that you can turn on and off separately. If it's not the desired behavior, then it makes sense for them to go in a single group. I don't know. I don't have a super strong opinion that that's actually the way we should do it. So if that doesn't work for people, you should tell us now, because at the moment you cannot turn off on or off individual resources in a group independently.
So Ken, you have something in there?
No, Eric.
Okay.
So so API Machinery talks about APIs being off when like the discovery data doesn't show them and you sort of can't request them. But you could have an API that is there but doesn't do anything. Would you agree that's cheating if it's on but like it never completes the backup, or is that?
I think it's never going to be a good user experience to have it like API that's sitting there in the system and you can write whatever you want to it and nothing is actuated.
So should I think about it as if something's on and there's a conformance test for it, then hit better and better passes?
In best case, that's super confusing. Worst case, it's a massive time bomb for when you actually turn it on.
Or DOS vector.
Yeah.
Yeah. So we have a bunch of cases like that today that we need to wrangle.
Hey, Jordan, you have your mic unmuted. Do you want to say something? All right.
No.
Okay. Just a time check. We have 7 minutes left. In terms of the agenda that you had for SIG storage, do you feel that it's been satisfied by this conversation, or are there things you need to wrap
yeah.
up?
So, what is the consensus? It sounds like keep pursuing out of tree.
Or can we look on moving even more things out of tree, and so that we can enable that use case? Like, do we need to modify the built-in controller to watch for an annotation, like I mentioned, so that it can defer, or do we need to make it easier to disable the built-in controller, or do we need to move that built-in controller code out of tree?
Like ideally, if we could
in?
start from scratch, we would put all the storage APIs external, and the controllers would be external, and we could take care of all of it. Right now, the fact that some of it is internal and external makes it difficult to mesh together, but we can.
You can always like make an extension API server, just copy paste or fork the existing APIs.
That's exactly why we created that mechanism.
Yeah. So like if you want to carry along the stuff that we already have and work from that, and also make it optional.
Well, if we do go the route of like adding another binary, adding another extension mechanism for something as core as volumes itself, I think that'll have to force the discussion in SIG cluster lifecycle about how do we actually start, expanding the set of things that we expose. How do we set those things up? How do we actually enable folks to install and use that stuff? I think we should start that conversation though. Yeah.
So we already done on out of tree, and we do have those difficulties, and that's why we propose to in tree, and also as alpha feature, right? So I just don't see the big disadvantage of, like, say, implementing everything out of tree, and we already present the reasons we need in tree, and so there are some functionalities like required by many users that cannot, let's say, not even easily, almost impossible to then like to be.
Yeah, no, and I totally hear you that there are a bunch of capabilities that these systems depend upon, like file system freezing, dynamic mount, unmount, things like that. My suggestion is that we start looking at those as more targeted, granular features that can be composed to do things beyond just snapshotting.
That's something, yes, like a phrase or something that could be a separate operation, but another thing we call in-place restore, and that's also a general functionality. Let's say user already have PVC, existing PVC, right? They just need to dynamically change their volume from snapshots without affecting the existing PVC, because
well, I mean, that seems like that's a feature for PVC to be reparented to a new PV. I mean, because you could orchestrate from the outside, where you create a PV and you can reassign the claim.
So all these are controlled by PV controller, which is in tray. So we have to do all the.
Right, but I think being able to reparent a claim to a new PV seems like a separable feature that might be useful without a snapshot in sight.
That's yes, but again, this functionality have to be inside of the.
Right, yeah, but that's not snapshots. What I'm saying is take the features that you need in core that make the out of tree stuff not be less than ideal. Let's come up with more granular features that impact the rest of the system instead of threading through snapshots in a very sort of monolithic way through all those things.
So,
like if we need hooks, let's do hooks. If we need dynamic mounts, let's do that. Was that?
Can we summarize the conclusion is come back to us with a small set of things you need to put in tree to make it
smaller
work?
And more general.
Well,
yeah.
Oh, general's open, but smaller.
A bunch of general features a bunch of general features that do general things doesn't necessarily in aggregate add up to a snapshot, right? Like a lot of what the work they're proposing and what they're trying to do is well thought through from the context of somebody who actually has a workload that they want to take a durable snapshot of and then turn it back up inside of a cluster using another pod or another stateful set. I'm not fundamentally convinced that you can break that down to a bunch of general features and then plug them back together and still tell a cohesive story.
Well, I mean, if you look at core Kubernetes, we split up pods, replica sets, deployments, services as separable objects. when we recognize that 99% of the users, they want to just create a service that brings all these things together into one thing, right? We've made this architectural decision across Kubernetes to create granular composable things. And it's paid dividends because we've been able to use those things in ways that we never thought about when we started, right? Because we broke things that way, you can do blue-green deployments on Kubernetes where other orchestrators bound them all together as one thing, and you can't do blue-green deployments, right? So I think we've seen this pattern of small, composable, granular, more generic components being paying dividends that we don't see right now. And I think this is another example of where as we start digging into these problems, every single one of those are problems that need to be solved, but they need to be solved in separable ways.
I agree, especially, well, for the lifecycle hooks, that seems like a generic component that would be more generically useful and that we have use for across the board. But if you read through the rest of the proposal in detail, I'm not sure that a lot of the rest of the functionality has a lot of use outside of a snapshot. It's what it was designed for.
Right. What we propose right now is the very basic functionalities to create snapshots and restore snapshot to volume list, delete. Those are just like for the basic functions and for snapshots. Yeah.
All right, so we've got 1 minute left. So the takeaway currently is to try and propose slightly smaller entry changes, and is that it?
Well, I think more generally, it's to revisit a number of assumptions, like should we move the in-core stuff out of core? Should we move a smaller set of things in core? What actually needs to be in the same API group? Is there a different way to address the pod level changes that need to be made? I think the pod level changes are the only things that are actually outside of the storage systems.
Yep.
Is that correct? Right. So I normally, if not for the pod proposals, SIG storage probably would have gone forward with this before we put the API review process in place. Right. So speaking of which, next week I want to talk about API review process. If you maybe we should start a thread on that on the Kubernetes SIG Architecture mailing list. So if people have thoughts or input on that, we should start that discussion there.
Yeah, I'll kick that off. I'm looking at the prior art around that, and so I'll send something out to the mailing list. So let's go and wrap it up. Everybody, thank you very much for your time as always, and we'll see you in a week for the regular meeting.
And thanks for the new meeting time.
Yes, thank you so much, Joe.
Thank you, Joe.
Thanks, Joe.
Well, I'm just glad that we can get a much larger discussion going on. It benefits everybody. Thank you, everybody.
Yep.
All right, take care.
Great.